This is just a really quick PowerPoint to show you how to differentiate sec, cosec and cot. There are some quick starter questions here for you to have a go at. So press pause now and have a go at these two. And I'll go through the answers then on the next slide, and then we'll have a look at sec, cosec and cot. If you haven't had a go at these yet, please press pause. I'm trying them myself first, but I'm going to go through the answers now. So the top one, hopefully you remember that when you differentiate tan, it becomes sec squared. So this one will become 2 sec squared of x. And thinking about the chain rule, I would need to times as well by the differential of the bracket. But this time when I differentiate the x, I just get 1. So I don't really need to worry about that. The second one's much more complicated. The second one is a product. So I need to differentiate the 4x and times it with the cos 2x, and then I need to do that the other way around. So if I differentiate 4x, I get 4, times it with the green bit, the cos 2x, plus, then I need to differentiate the green part. And when you differentiate cos, you get minus sine. So if it's cos of 2x, that'll become minus sine 2x. I need to times also by the differential of 2x, so I've conveniently left a little space there to fit in that 2. And then I also need to times this by the yellow function, which was the 4x. So I'm going to write my answer, it's 4 cos 2x minus, and then I'm going to times the 2 and the 4x to give 8x sine of 2x. Okay, so if you look at this little table, the top 3 facts are ones that we've already proved in previous lessons of PowerPoints. So we know that if you differentiate sine x, you get cos x. If you differentiate cos x, you get minus sine x. And if you differentiate tan x, you get sec squared. So those 3 facts we already knew. The 3 underneath are the new ones. If you differentiate cosec x, you get minus cosec x cot x. And if we differentiate sec x, it becomes sec x tan x. And then finally, if you differentiate cot x, you get minus cosec squared x. Now, all 3 of those are in the formula booklet, so you don't have to memorize them. Here's what it looks like in the formula booklet. So this is the top of the differentiation page. So let's have a look at what we can see. The top one is the quotient rule. Then we've got the tan, and then sec, cot and cosec. So the answers to each of those differentials are all there. So you haven't got to memorise them. You might be asked though to prove them in an exam, and they are actually quite easy to prove. So that's what I'm going to do on the next few slides. I'm going to go through the proof of each of these. So let's start with y equals cosec of x. Let's see if we can differentiate that. Now, using facts that we already know, we know that cosec of x is the same as 1 over sine of x. That's the definition of what cosec is. It's 1 over sine. So we could write this as sine of x to the power of minus 1. And if we write it as that, then it becomes a little bit easier to differentiate. When you differentiate a bracket with a power, you bring the power down in front, and then you take 1 off the power. So that minus 1 goes down to minus 2. And then we times by the differential of the bracket. When you differentiate sine, you get cos. Now I'm going to write that in a slightly different way. So I'll leave the minus 1 and the cos x on top. But I'm going to take this sine x to the minus 2 back down to the bottom and write it as a sine x squared. Remember, that's what negative powers mean. You can take negative powers down to the bottom and make those powers positive. And then I'm just going to write on the bottom the sine x. I'm going to write it out twice, Sine x squared just means sine x times by another sine x. Now I know what I'm aiming for. Look at what we're aiming for. We know what the answer is going to be. Minus cosec cot. So let's see if we can see where they are going to come from. What I could do here is I could write the minus cos x with one of the sine x's underneath it. And then if I write multiply by 1 over sine x, can you see that all I've done there is I've split the top up into cos x times 1 so that I can have two separate fractions for each of the sine x's. And then I think it's a little bit more obvious where these answers are coming from. 1 over sine, by definition, is cosec. That's what we call cosec. It's 1 over sine. So I can see where that bit has come from. And then the other part, we've got cos over sine. Now, cos over sine looks a little bit like tan, doesn't it? But it's upside down. Remember that tan is sine over cos. Well, this is cos over sine, so this is tan, but upside down. It's the reciprocal of tan, and that's got a name. 1 over tan is the same as cot. So there's that first one proved. On the next few slides, I'm going to go through the proof of the other two, but if you want to press pause now and try them yourself, you can do, because the proofs are very similar to this one that we've just done. So press pause now, see if you can prove the other two on your own, and then on the next two slides then I'll go through each of the proofs. So I'm now going to go through the proof of differentiating sec of x. First of all, I'm going to write sec as 1 over cos, because that's what sec is by definition. And then I'm going to write this as cos of x to the power of minus 1. Now I'm going to differentiate it. When you differentiate a bracket with the power comes down in front. You take 1 off the power, so the minus 1 becomes minus 2. And then you times by the differential of the bracket. When you differentiate cos, you get minus sine. So it would be minus sine of x. And on this one, we've got a minus times a minus, which is a plus. There's a sine x. And then I'm going to take the cos x to the minus 2 down to the bottom and make it a cos x squared. So I've just taken the negative power down to the bottom. Now I'm going to split this up into two separate fractions. So I'm going to write sine x over cos x. But then on the bottom there was another cos x. So if I write another cos x on the bottom, I'll just put a 1 on top. Now this is familiar to us. Sine x over cos x. We know that that's the same as tan x. And then this bit should also be familiar to you. 1 over cos has got a special name. 1 over cos is known as sec. So my final answer is tan x sec x. Or if you look at the answer, you could write it the other way around. It doesn't make any difference. Sec x tan x. So I'm going to go through the last one now, which is differentiating cot of x. So first of all, I'm going to write down what I know about cot. I know it's 1 over tan. So I could write this as tan of x to the power of minus 1. And then when I differentiate this, I bring the power in front. Then I take 1 off the power, so that becomes minus 2. And then I times by the differential of the bracket. If I differentiate tan x, I get sec squared x. So if I simplify this, I'll keep the minus on the top, and I'll also keep the sec squared x on the top. And I'm going to take this tan x squared to the bottom. And then I could split this up into two separate fractions because I've got a minus sec x over tan x, and then another minus sec x over tan x. I'm just having a rethink actually. I think I'm going to do this in a slightly different way. There's a few different ways of getting to the end of this proof, but can I remind you of a trig identity that you learned in the trig booklet, and that is that sec squared is the same as 1 plus tan squared. And I think that could come in handy here, because on the top we've got a sec squared with a minus in front, so I could use this trig fact but just make everything negative. So minus 1 minus tan squared x over tan squared x. Then I could split this up into two separate fractions. So minus 1 over tan squared x and minus tan squared x over tan squared x. And then I've got minus 1 over tan squared. Well, we've got a name for 1 over tan. 1 over tan is known as cot. So 1 over tan squared is known as cot squared. So this is minus cot squared. And this other fraction is just 1, isn't it? Because if you divide anything by itself, you just get 1. And then finally, can I remind you of another trig identity that you've learned this year? 1 plus cot squared is equal to cosec squared. So this does look like 1 plus cot squared, but it's the negative of that. So it's actually minus 1 plus cot squared, which is minus cosec squared. Now that's definitely not the only way of getting from that fraction to the final answer, but it is one way. But you needed to know both of those trig identities for this method, so it's good revision of those as well. Right, so we've proved all 3 of those. Remember, you could be asked to do any of those proofs in the exam, but now I'm going to have a look at some examples. So in this first one, we've got sec of 5x. So remember that these are in the formula booklet. I would look straight to the formula booklet and I would see that sec becomes sec tan when you differentiate it. So if it's sec 5x, it will become sec 5x tan 5x. So far I'm just following what the formula booklet tells me. Then I'm remembering that I need to use the chain rule. So as well as differentiating sec, I also need to differentiate the bracket. When I differentiate the bracket, I get 5, so I need to times all of this by 5. So I've left a gap at the front because I knew that that 5 was going to go there. So there's my final answer, 5 sec 5x tan 5x. The next one's very similar, it's sec again, and sec becomes sec tan. So for this one, it will be sec 3x squared tan 3x squared. And then I need to times by the differential of the bracket. If I differentiate 3x squared, I get 6x. So I'm going to put that in front. 6x sec of 3x squared tan 3x squared. The last one, I would write this as cot of x cubed. I find that easier when I'm differentiating. And now I'm differentiating a bracket with a power. So with brackets with powers, we bring the power in front. Then we take one off the power, so the cube becomes squared. And then we times by the differential of the bracket. Well, when we differentiate cot of x, we get minus cosec squared. So I've taken that straight from the formula booklet. And then I'm just going to tidy that up a little bit. I'll bring the minus in the front. Minus 3 cot squared x cosec squared x. So have a go now at some questions from the booklet. On page 14 there's all sorts of different questions there, but you might want to look out now just for the ones with sec, cosec and cot.